Welcome to Module 4. We're going to start going up the OSI model. As you know, OSI and the TCP/IP protocol suites are similar, except the TCP/IP has fewer layers in it. But we're going to start at the physical layer and work our way up as we go through. So this chapter is on the physical layer, starting at the bottom. And the question is, why do you want to do this? I usually tell my students that if you've got a networking problem, start with the physical, especially when you're troubleshooting, because usually then it's just power's not on, cable's not plugged in, wrong port. A large percentage of problems can be resolved just by focusing on the physical layer. So the series of lectures for this physical layer section, I'll probably do one on the purpose of the physical layer and a brief, some of the characteristics. Then we'll go into lecture on copper cabling, then a UTP cabling, fiber optic, wireless, and that pretty much covered most of the medias we have been exposed to or could be exposed to in what we do. So just know that if you're going to have two machines talk to each other, you need a physical layer. And sometimes think wireless is still a physical layer. So if you got two devices talking to each other, you definitely need this. So even if you do a wireless router, guess what? You still have certain components. And most of you are probably more familiar about this kind of a router than you are with a physical router for an Ethernet, because most of us have one of these in our house. And on it, you've got wireless antennas based on which one device you're using. Some have internal antennas. Some will even have external antennas, and maybe more than one. Could be up to 3 or 4 based on how fast you got your module running, and if it's using multiple in and multiple out MIMO technology to improve the signal and increase the speed. So in this case, this picture has embedded antennas. It has definitely several Ethernet ports. The one at home, I think I've got, I think the thing I got plugged into it is my printer. I don't think I've even got a computer plugged into one. But if I had a desktop computer, I would probably have that plugged in also. And then you have one that indicates that it is an Ethernet internet port. So you've got all 3 access. Of course, this is your PowerPoint, and then of course these will tell you if you've got powers on and if you've got access to the internet. They come in different various shapes and sizes. But when you look at a wired connection, what is it? That means I got a wire. I got a wire that comes from an Ethernet port on laptop, desktop, physical Ethernet cable that runs into one of the Ethernet ports. Those Ethernet ports are called interface cards, network interface cards. So every one of those Ethernet ports that are in your router or in your PC, that is a network interface. And every network interface is going to have an IP address. And an IPv4, you're going to have an IP address and a subnet mask. And we'll get more and more into this, but the subnet mask tells the switch how to treat that IP address. If there's a 1 in the subnet mask, it's network. If it's a 0, it's a host. So just know that your devices all have network interfaces and they do have addressing. Now, how do I connect to a wire using Ethernet? You just plug the cable in. Match the shape. Usually it's got a clip to hold it in place. You just have to look at your interface, which way the clip goes in. They're not always equal. Even the types of cable. So this physical layer, it's the OSI physical layer. So what's that mean? It's going to transmit bits that the data link layer had sent it based on, and then the data link layer is going to manipulate or tell the physical layer, is it going to be electrical, wireless, electronic, or light, based on what kind of media I'm connecting to. So on this packet that's being sent, or on this frame that's being sent, for the Ethernet frame, because that's what the physical layer is dealing with, you've got your data, you've got your TCP IP segment. Now remember, I told you needed to worry about the protocol data units, the PDUs. So you got data that you're sending. At the TCP level, it's a segment. At the Internet Protocol layer, it's the packet. And at the Ethernet layer, it's the frame. So just at the physical layer, you're going to be sending the frame down. And you can watch a little video as far as how it goes through. Yeah, I'm not going to watch it. And go ahead and do the little quiz. Now let's look at, and I really suggest you watch these quizzes, help to reinforce the information that you're being given. Now let's look at some of the physical characteristics of. Now, there are definitely several different standards that are being used with this. Now, the ones that we're using, you got ISO that's defining like the protocol layer suite that we're using right now. You have the TIEIA are telling you how how are cables, Ethernet cables, wired. So IEEE is talking about how the data is being sent back and forth. So a lot of different organizations, the FCC and the wireless network tells you this, but all of these are standards that are used to help make sure the data gets from point A to point B. Now, physical layer, which is here they're identifying it half of the data link, because you've got to specify how am I going to connect to the physical layer. So what protocol am I going to use? How am I going to send the data out? And you've got several different standards that are all related to try to get this sent out. And as you can tell, TCP IP standards, other than the data link and physical layer, is all controlled by one task force. But everything down below is handled by a lot of different groups. Now, physical components, there are basically three major function areas. There's physical components, there's how is data encoded, and how is it being signaled. Now, the physical components pretty much say, am I sending in bits? Is it going to be cable? Is it going to be wireless? What is the physical component? And what are the physical interfaces? Do you have an Ethernet port? Is your port on your switch a fiber port? So those are some of the physical things you need to worry about. Now, encoding is, how do I convert the data that you're sending, that you want to send, into a group, based on whether it's going electrically or wirelessly or fiber via light. You've got to encode it. You've got to put it into the media, whatever the media will understand, you have to put it in there. So you have to find a way to represent a 0 or 1 in the media's format. Our Ethernet is all based on electrical signals, and it's based on voltage. So if it gets to a certain voltage, it's a 0. If it gets to another voltage, it's a 1. So it allows you to, so you got 1 bit, so it was a low and a high voltage. Now, when it comes to signaling, it basically says, how am I going to transmit that data? So over copper, you're getting voltage over time. Over fiber, what am I getting? I'm getting light pulses over time. And then wireless, I am getting voltage, you're getting, and then based on what type of encoding it's using, whether you're going to get amplitude modulation, which is the height of the waves, whether I'm going to get frequency modulation, whether it means I'm faster and slower to regulate a 1 or a 0, or I'm going to get phase modulation, where it says I'm going to check for changes in is the previous wave, I'm comparing two waves, are they in or out of sync? If they're out of sync, in this case, if they're 180 degrees out of sync, it's a 1. If they're in sync, it's a 0. So wireless has those options, and in some cases, I think frequency is not used very much, but we'll use amplitude and phase to get together to get more and more data represented, to be able to send more and more data over wireless than ever before. Now, there's a term called bandwidth, and bandwidth is basically, it's a combination of a couple of things. It's properties of your physical media, and it's also the what technology you're choosing to signal and detect signals. And then, of course, you're going to get different types of bandwidth. How much data, how many bits per second am I getting? And bits is BPS, bits per second, kilobits, megabits, gigabits, terabits. And all they are is how many more bits. Am I going to get 1,000 bits, 1,000,000, 1,000,000,000, or 1,000,000,000,000 bits per second? Now, right now, most of our Ethernet cables are probably running between 10 megabits and 100 megabits Ethernet. Some of the wireless are getting up to some of those levels. They're not quite. There's some gigabit wireless. It's close. So we'll see how that goes. Now, there's a few terms you need to understand when it comes to bandwidth, and the three major terms is latency. Latency is the amount of time, including delays, that the data takes to get from one point to another. Throughput is basically, it's a measure of how much, the measure of the transfer of bits across your media in a given point of time. And a lot of factors come into play. How much traffic you're sending, the type of traffic you're sending, and then based on all the other network devices that is along the path between your source and destination, that can slow or speed you up. And then the third one is, how do I know is usable data? How much usable data is available to you? How much can I download, and how much can I send up the line? Now, there are several online tools that allow you to test that, for any network connection that you may have. So I don't think there's a lab on that, but you may want to just check your net speed, your network speed, and see how much you're getting up and how much you're getting down. So go ahead and do the Check Your Understanding quiz. I'm not going to go through it right now. I'm not going to give you all the answers. And I'll end this video, and we will move on to copper cabling. Have a nice day. Bye-bye.